Hello. In this video, I'll show you how to get started with the NCV7192 Evaluation Kit from onsemi. The NCV7192 chip is a bridge signal conditioning interface with analog or sent output. It processes differential signal from external resistive bridge sensor. When NCV7192 is combined with such sensor, it can accurately measure pressure, force, torque, or some other physical quantity. It is suitable for automotive safety applications. NCV7192 Evaluation Kit is intended for customers to get familiar with this integrated circuit. The kit package contains main board, piggyback with the NCV7192 chip, Wheatstone bridge emulator, USB cable, and 12-volt power supply. With this evaluation kit, you can program, calibrate, and read data from the chip. Resistive bridge emulator allows you to easily stimulate chip's input. Customers can also connect their own bridge sensing element using this connector, or NTC using this connector, or whole sensor module with transducer and NCV7192 integrated circuit using this connector. For basic experiments, you should connect emulator and piggyback with the chip to the main board. To be able to work on the PC with this kit, you also need software which you can get from onsemi website or onsemi customer support. I also recommend getting Evaluation Kit User Manual, an NCV7192 Configuration and Calibration Application Note, which outlines setup steps and describes functionality in more details. For operating the evaluation kit, you need to plug 12-volt supply to this connector and connect the main board via this USB connector and a cable to the PC. You can run the software by launching NCV7192.exe file. It directly runs the software. No installation is needed. If everything is connected properly, you'll see a green USB Connect button in upper left corner. If the kit doesn't connect automatically, try to click on USB connection menu and select Manual Connection. List the available COM ports and select the correct one. Sometimes it takes longer time to install the drivers for the first time after connecting USB port to the PC. The software has a few tabs at the top. There is Main tab, on which you can switch between normal mode, calibration mode. You can read device pressure or temperature output, or in lower left corner, you can show hardware parameters like supply voltages, temperature, or you can set baud rates used in calibration mode. NCV7192 device on the evaluation kit is delivered unprogrammed, so you cannot get any output for the first time. But for program device, the output can be read once by clicking on Read button, or by selecting Auto Read checkbox, you can plot a graph. Output from real sensor can look, for example, like this. Before going to Next tab, let's enter calibration mode by clicking on Calibration Mode button. Now when we switch to Shadow Memory tab, you can see device registers. The device has two types of memory. One is EEPROM. Second is called shadow memory, which is volatile type of memory, so it loses its data after reset. After powering on the device, the content from the EEPROM is copied to the shadow memory. Then the device uses shadow memory for its configuration. So if you modify shadow memory, it has immediate effect on device functionality, even with the old EEPROM content. After entering calibration mode, I strongly recommend saving original device content by clicking on File, and then on Save Content to File button. Let's enter a file name. I recommend saving original device content because on certain memory locations there are stored some temporary trim coefficients from production testing. Those coefficients will be important for accurate calibration and will be later rewritten by final calibration coefficients or by our experiments. On the left upper side, you can select certain register group. On the right side next to each register, you can read or write specific register, or in the upper right corner, you can read or write all device registers at once. Those read and write operations have impact only on shadow memory content. Then there is Program button. Clicking on this will copy content from shadow memory to the EEPROM. When you need in the future to load saved config, you need to be in calibration mode. Then you click on File, Load Content from File, select Proper File, and click Write, and then Program. By this, you can revert original stored EEPROM content or load some other previously saved settings. Let's move to Next tab, Coefficient Calculation. This tab serves for semi-automatic calculation of the device calibration coefficients and is more complex. Last tab is NTC tab, which is intended for setting NTC temperature measurement coefficients. Last important thing is the Wheatstone Bridge emulator window. You can open it by clicking on Window and select Emulator. You can even drag and drop this window where it has the most comfortable position for you. Now I'll show you how you can perform bridge sensor calibration using the Evaluation Kit and Wheatstone Bridge emulator, which will emulate pressure signal. Let's assume that we have fresh unprogrammed device. I will not go into details about math behind the calibration. You can read it in NCV7192 configuration and calibration application note. I'm starting from normal mode. USB is connected. Let's open emulator window. In the emulator window, please click on Load CSV button. In the software folder, go to Documents for GUI, then to Sensor folder and select Sensor Ideal CSV file. By default, first emulated sensor is selected. It is possible also to select some different one. Now click on Init button. By this, the emulator should give some output. On the Main tab, enter Calibration Mode by clicking on Calibration Mode button. Now you can store original memory content to file in case of overwriting important data. At first, we need to set input front-end gain and offset for our sensor. This will ensure that the input ADC range will be used optimally. In Shadow Memory tab for pressure measurement settings, check if registers PG1 is set to 1, PG2 is set to 0, and P-off is set to 32. This is the starting point. Otherwise, the front-end optimization will fail. Now go to Coefficient Calculation tab. Set on the emulator minimum output voltage by setting lowest pressure. You can move the slider or write pressure number manually. Now click on Measure Min DP button. This will strobe raw ADC value for minimum pressure. Set maximum pressure on the emulator and click Measure Max DP button. Raw ADC value for maximum pressure is now strobed. Field ADC target means how big portion of input ADC range will be used. In our case, if we leave 80%, this ensures that 20% of the ADC scale will remain as margin and ADC will not clip. On the right side of the Calibration tab are now calculated new front-end gain and offset ideal settings. This needs to be stored into memory. In the upper right corner, select Front-end Gain Offset option and click to Copy to Shadow Memory button. This copies the values to the Shadow Memory tab only. It is not yet in the device. Go to Shadow Memory tab and click to Write button. Input stage is now properly set. Second step during calibration is to calculate coefficients for the DSP. By this menu, we choose Device Output Type. For sent output, we need to specify just minimum and maximum code matching with lowest and highest pressure. For analog output, you need to specify analog output range in percentage, matching lowest and highest pressure. And you can also see that for analog option, there is extra table called temporary values. NCV7192 analog output has certain gain and offset error. It is needed to include trimming coefficients from production testing to our calculations. You load those trimming coefficients by clicking on Load from the chip button. For this, you need original device memory content from the production. In the fields below, you should see some non-zero values. Let's set up our device for analog output. For the send output, the procedure is almost the same. You just don't need to take care about output stage gain and offset trim codes. Now let's move to strobing pressure and temperature points. We can strobe maximum 4 pressure points at 3 temperatures, but for simplicity, we will use less points. In this field, we select, for example, that we want to calibrate on 3 pressure points, and here we set just 1 temperature point. When we move with the emulator slider, you can see that the selected emulated sensor values goes from value 20 to value 456. This is no unit in the software. Just ratio between these values is important. In this field, we need to pre-fill target calibration pressures. In our case, P0 is 20. P1 we can select, for example, 200, and P2 is 456. Now click on Measure PT Points button. New window will appear. Because we will strobe just 3 points, we will use just these 3 buttons for P0T0, P1T0, and P2T0. Let's set on the emulator pressure value 20, strobe P0T0 point. Now set emulator pressure 200 and strobe P1T0 point. Now set emulator pressure 456 and strobe P2 T0 point. Click on the Copy to Coefficient Calculator button. This will copy strobed samples to Table on the Coefficient Calculation tab to the lower table. You can now close Window for strobing the PT points. On the right side here, you can see that the tool automatically calculated coefficients for the DSP. We need now to copy them into device memory. On the right upper side, select Calibration Coefficients from the menu and click on Copy to Shadow Memory button. Now on Shadow Memory tab, click Right button to send the data to the chip. We can also click on Program button to store all coefficients in the EEPROM. This will ensure that the calibration will stay in the device even after leaving calibration mode or reset. But for debug purposes, this is not needed because NCV7192 chip can enable output even in calibration mode. Now the device is calibrated. There is a jumper on the board for selecting analog or send input receiver. In our case, we need to put it to analog position. Let's go to Main tab. Let's set 20-second time axis and enable output by clicking on Enable Output button. Now we enabled auto read. The graph should start displaying data. When we move with the pressure emulator slider, you can see that the output starts reacting to the input settings. And that's it. The evaluation kit serves mainly for demonstration purposes so the emulator and analog meter readings on the board can have some error. But the NCV7192 device accuracy itself is below 0.25%. NCV7192 can also read bridge temperature or NTC temperature. It is not shown in this video how to set it up, but you can refer to the user manual or other documentation. Thank you for watching, and I hope this guide helps you get started with the NCV7192 Evaluation Kit. Have a great day and happy testing!